Hi everyone, in this video I'm going to go through an example of a game where each of our players have three possible strategies. So we have a 3x3 matrix here. And in the video I'm just going to demonstrate some of the skills that I've spoken about in other videos. So finding Nash Equilibrium, dominant strategies, talking about dominance in terms of being strict or weak, and also discussing dominance between strategies. So I'll link to those videos below if you need any more background to these things. So in our game here, player 1 could either go S, M or L, so small, medium or large. Player 2 can also either go S, M or L. The first thing that I'm going to do here is find our best responses for each player. So I'll start by imagining that I'm player 1 first. If player 2 plays S, we would be on this column here. And from player 1's perspective, well, they could go S and get 6. They could play M and get 2, or play L and get 12. 12 is the larger payoff out of all of the options here. So L will be player 1's best response to player 2 playing S. If player 2 played M, we would be on this middle column here. Player 1 could play S and get 4. M and get 5, or L and get 10. Again, L will be the best response here because 10 is the largest payoff. It's bigger than 5 and 4. If player 2 played L, we would be on this last column here. Player 1 could play S and get 1, M and get 3, or L and get 4. 4 is the biggest payoff here out of all the options. So L will be player 1's best response to player 2 playing L. Hopefully you can see here that L is a dominant strategy for player 1 because regardless of what player 2 does, player 1's best response is always to play L. I'll talk a little bit more about what kind of dominance we're seeing here in a bit, but before we do that, let's just think about player 2's best responses first. Alright, so from the perspective of player 2, if player 1 plays S, we would be on this top row here. Player 2 could play S and get 4, M and get 6, or L and get 0. M will be the best response for player 2 here because 6 gives the highest payoff. If player 1 played M, we would be on the middle row here. Player 2 could play S and get 3, M and get 3, or L and get 6. 6 is the largest payoff here, so player 2 would choose L as the best response to player 1 playing M. And if player 1 played L, we would be on the last row here. Player 2 could play S and get 9, M and get 11, or L and get 5. The best response here then would be to play M for player 2 then, to player 1 playing L, because then they would get that higher payoff of 11. So here player 2 does not have a dominant strategy because when player 1 changes what they do, player 2's best response changes also. In some cases it's M, in some cases it's L. We do have a Nash Equilibrium though. It's here associated with player 1 playing L and player 2 playing M. This is the only Nash Equilibrium of the game. It's the only outcome that's the intersection of two best responses. So that's Nash Equilibrium. I did want to talk a little bit more about player 1's dominant strategy here. The sort of dominance that we're seeing, it's called strict dominance, because the payoffs associated with playing L for player 1 are strictly better than the payoffs that they get from any of the other strategies that they could take. Now here, when I say strictly, I just mean always greater than, never equal to. So 12 is greater than 2 and 6, strictly. 10 is strictly larger than 5 and 4. And 4 is strictly larger than 3 and 1. So player 1 has a strictly dominant strategy. Now, if this is difficult for you to see, if you find it confusing with all the numbers, one strategy that you can take is just to remove player 2's payoffs from the grid. It makes it less messy and easier to see. So if we do this, well, we would be comparing the rows, but down each column. So you can see that all the numbers in the last row corresponding to player 1 playing L, they're always strictly better than the numbers above them. So 12 is bigger than 6 and 2, 10 is bigger than 4 and 5, and 4 is bigger than 1 and 3. So that's another way to look to find strict dominance if you're getting confused by the numbers. Now, there are more complicated discussions that we can have here around dominance between strategies for our players. For instance, when I said that player 2 didn't have a dominant strategy, that's because there wasn't one strategy that player 2 could take that dominated all of their other possible strategies. But we can talk about dominance between strategies. So for instance, and I'll just take player 2, I'll remove player 1's payoffs just so we can have a look more clearly at what player 2 is facing. And I'm going to start just by blocking out L and comparing S and M. So I'm thinking about dominance relations between strategies here. And you can see that M for player 2 is at least as good as S in every case and is strictly better than S in actually 2 cases. 6 is bigger than 4 and 11 is bigger than 9. Now this actually corresponds to what we call weak dominance. Weak dominance occurs when a strategy is at least as good as another strategy in every case, and strictly better in at least one case. So there isn't a strict dominance here because M isn't strictly better than S in every case. We have these 3s that are equal, but we can say that M weakly dominates S for player 2. Now let's look at what happens if we compare S and L. So I'll block out M. You can see that sometimes S is strictly better than L. So 4 is bigger than 0 and 9 is bigger than 5. But if player 1 played M, L gives a better outcome, so 6 is greater than 3. In this case, we would say that S and L are intransitive. Intransitivity happens when 2 strategies are neither strictly or weakly dominant and they're not equal to one another. Before I finish the video, I did want to show you another strict dominance, but just between kind of 2 strategies. So let's change this 6 to 2. And if we focus on the relationship between M and L, so I'll block out S. And you can see, hopefully it's clear to you that M is always strictly better than L. So 6 is bigger than 0, 3 is greater than 2, 11 is greater than 5. So if this were the case, we would say that M strictly dominates L for player 2. All right, that's it. That's solving a 3x3 matrix, talking about Nash equilibrium, dominant strategies, and dominance relations between strategies. Thank you so much for watching. I really hope that the video helped. If it did, please like and subscribe. Have a good one, everyone.